Welcome and hello. This is a support video in HEC HMS. And in this support video, I'm going to be answering a question as best I can regarding interpolated precipitation. So let me just put the question up on the screen here. And it's this. I have a question regarding inputting depth, duration, frequency data based on stations, not on subbasins. I have 25 rainfall stations, each with depth, duration, frequency values for different return periods, ranging from 2 years to 50 years, and then the storm duration ranging from 1 hour up to 24 hours. Or I'm sorry, this is the depth data from 1 hour to 24 hours. So we're looking at a 24-hour storm. How do I input station-based depth, duration, frequency data into HMS and assign it to the appropriate subbasins? Also, how should I input latitude and longitude data into HMS for each of the stations? So in this case, station, I'm pretty sure is referring to the precipitation gauges. And this is support video 3. Support video 2 had a similar question, and I answered that in a little bit different way. If you're curious to check it out, I used the frequency storm precipitation method. But for this support video, I'm going to use the interpolated precipitation method in the MET model. Okay, what I have on the screen here is the model that I set up to answer this question. I'm going to toggle off the terrain data real quick. So view, map layers, and then turn terrain off. So what you can see a little easier now is the model has 3 subbasins. Let me open up the basin model here. There's basin 1, basin 2, basin 3. And then there's a sink, there's a couple of junctions and a reach. The sink is right here at subbasin 3, so the water's flowing in this northern direction. Also, if I back out a little further, I've got a few blue dots on the map. This represents the location of the precipitation gauges. Now, if you have 25 precipitation gauges, you'll have 25 dots on your map and a lot more data to input. However, I just wanted to make a simpler, smaller model to explain the concepts without adding 25 different gauges or subbasins. So right here is subbasin 1, and this is rain gauge A. This is subbasin 2, which is closest to rain gauge B, and this is subbasin 3, that's closest to rain gauge C, as I'm calling it. However, it's not like one particular rain gauge is assigned exclusively to one subbasin only. Rather, using the interpolated precipitation method, I'm going to use the inverse distance squared interpolation method. We'll get to that in just a moment. And what that means is the amount of precipitation that falls on any one of these subbasins is influenced by all 3 of the precipitation gauges, and it's going to be influenced by the precipitation gauge that's closest to it. So subbasin 2 right here will have will be most influenced by rain gauge B right here, but it will also have some influence, be slightly influenced by rain gauges A and C. So this is the basin map. We talked about that enough for now. Let's go ahead and zoom back in. Over in the Watershed Explorer, I'm going to expand my Meteorologic model. I have 3 Meteorologic models. There's one for 10-year data, one for 100-year, that's 100-year data, and then this test Meteorologic model. I'll talk about that at the end. I have a control specification. This is just going to be for the first day of the year 2000, which is the default. I have the terrain data here, and then here is the time series data. I have 6 different precipitation gauges. Now, you may be saying, hey, you only have 3 gauges on the map. Well, I do have 3 gauges, but what I did for each gauge is I assigned it data for the 10-year storm as well as the 100-year storm. So to create a precipitation gauge, you'll go up to Components, Time Series Data Manager, select Precipitation Gauges. It's the first data type there is. Click New, give it a name, click Create. I'm going to click Cancel, though, because I've already done my creation. Then after you've done that, you're going to go ahead and select the time series data, expand that folder, expand precipitation gauges folder, and then click on the gauge you want to define the time series data for. Now, in this case, I'm using DSS data, and I will cover how to define that data later in this lesson. But in this interface here, I specified the file name. This is the path to the DSS file, and then the file path itself within that DSS file. The units here is incremental inches, and the time interval is 1 hour. Now, these fields are grayed out because they're read in from the DSS path data. If I happen to select manual entry, then I would have to manually select the units, the time interval, and then define the data. What's also important is the latitude and longitude. So this right here represents the latitude and the longitude of this gauge A. Now, if I select gauge A for 100 year, I should have the same latitude and longitude data. And boom, I do. Now, gauge B, that's located down here, we're going to have a lower latitude and larger longitude because this is the Western Hemisphere. So if I click on gauge B, yeah, we have different numbers here for gauge B 10 year and gauge B 100 year. It's the same numbers. And then gauge C will have different latitude, longitude as well. Okay. Okay, on to defining the DSS data. So what I'm going to do here is open up DSSVue. And then what I'm going to do is just walk through some of the same steps to generate this DSS file and path. I'm just going to save it onto my desktop though, because the actual data is already saved in my project folder. All right, so the first thing is to create a DSS file. I'll just call it data, put it on my desktop. And then what I want to do is go up to data entry, manual time series. You can input parts A through F if you want. Actually, some of these parts I really should input. Okay, so for part C, that's going to be precipitation incremental. Part E, I'll go with the 1 hour time step. So I'll be inputting incremental precipitation data on a 1 hour basis. For part F, I'm going to go ahead and type in gauge A dash 10 year. So then this data is associated with gauge A for the 10-year storm event. I'm going to go ahead and start the data at the year 2000, and that'll be at midnight. And then the units here will be in inches. And then the type here is going to be period cumulative. So now I need to actually define the data. I need to have 24 records of incremental precipitation that's associated with gauge A and the 10-year storm event. To do that, I'm going to open up Excel. What I've done here is I have data for gauge A, gauge B, and gauge C. I just made this data up. This is 10-year data. I have a separate worksheet in Excel here for the 100-year data, but let's just focus on 10-year for right now. Here is some dummy data. I just made this data up. This is the total amount of precipitation in depth, 0.56 inches, that falls during a 10-year storm at the most intense hour, 1 hour, over a 24-hour storm duration. The next row down represents 2 hours, so that's 0.90 inches of total rainfall over the most intense 2 hours of rainfall during the 24-hour storm event. During 3 hours, the sum is now 1.17 inches, and so on. After the entire 24-hour storm, we have 2.75 inches of precipitation for a storm that is the 10-year return, the 10-year recurrence interval. So you may already have this data, and if you do, you may be wondering, how do I get that into a time series? Because after all, in DSSVue, we need 24 records right here. So what I did, and I'm not sure if this is normal or not, but what I synthesized a 24-hour precipitation data. So you could think of this as a hyetograph. I assume that the 8th hour here, 0.56, has the maximum precipitation, 0.56. And then I assume that the 7th hour had the second most precipitation. And I made sure that these 2 hours, 0.56 and 0.34, summed up to this 0.90. And then 3 hours, I colorized it to kind of help me figure it out. So that would be right here. These 3 hours right here, 7, 8, and 9, should sum up to 1.17. And then 6 hours, 12 hours, and 24 hours. So the sum of all of these records here should sum up to the 24-hour sum, 2.75. And that's true for both gauge A and gauge B and gauge C. Okay, all of these numbers are pretty much the same though. I mean, 2.75, 2.98, 2.84. It's all pretty much in the same local area anyway. All right, so what I did is I grabbed this data here from Excel, and then I went Control C to copy, went back to DSSVue, and I put my cursor here on the first record, and then I clicked the paste button. I think Control V would also paste, and that looks good. So it looks correct. I'm going to go ahead and save. I don't need to return to the data entry screen. And then let me just go ahead and plot this hyetograph, which again is for gauge A on the 10-year storm. So that is how that works. I'll go ahead and close that. If you need to make 6 records or more, like I did, then a quick way to make a duplicate without having to go data entry, manual time series, and fill out all this data again, because all you really need to change is your part F and your values, is go right click in DSSVue and then duplicate. And say I want to do gauge A for the 100-year storm. I'm just going to type a 10-year. Oh, yeah, I can change it there. You can change it up here in the path name and tab off and it updates the parts, or you can make the edit down here in the parts, tab off, and it updates the path name. Either way is fine. Go ahead and click OK. All right, so new record has been created. It's right here. We can see part F now says 100 year. Let me make this a little bit skinnier. And then what I would do is just double click, or sorry, right click and edit. Hold on, I have to click off, right click and edit. There we go. And now all I'd have to do for the 100 year is just update these values here. And I am purposefully setting this first record to 0 because the 24 hours of data is right here. Also, if you have trouble editing in this interface, go up to edit and then allow edits, allow editing. This is already checked for me, but for some reason it may not be checked for you. So just go ahead and click allow editing. This will be grayed out and you'll be able to edit these records. So I'm going to go back to Excel. I'm going to go over to my 100-year data. Now this has larger numbers, but I essentially did the same thing. So for my gauge A 100-year data, I'm just going to copy this data onto my clipboard, come back over here to Excel, or I'm sorry, to DSSVue, paste, Control V. Okay, that worked. File, save, and then that's saved. All right, so if I wanted to compare this data against each other, I could just plot it. And here we have what in light blue here, cyan, this is the 10-year hyetograph, and then this is the 100-year hyetograph. There was a little bit of judgment as to what this hyetograph should look like. However, I was constrained by the data in this table right here, meaning the first hour had to be, the most intense hour had to be 0.56 inches. The two most intense hours had to be 0.9 and 1.17 and so on. So let's go back to HMS now, and then we can close or minimize DSSVue. Then what I would do is once I have the precipitation gauge selected, I would go ahead and click the folder icon button here, navigate to that DSS file, which is wherever you saved it, and then click OK, click select. I'm not going to do that, but then click on this button right here, and then select the appropriate path here with the help of the label that you provided yourself in Part F, the gauge letter as well as the return period. Okay, let's finish things up here. We have the meteorologic model, which I said is 10 years. And what I'm doing here in the components editor, you can see the precipitation method is interpolated precipitation. If you want more details about this method, I've created a lesson. It's lesson 49, meteorologic models, precipitation, interpolated precipitation. So I'll leave a link to that in the video description. And I'll also leave a link to the exercise 1, which is what I used to delineate the watershed like you're seeing here. Because I should probably also mention that each of these subbasins are georeferenced. In the GIS menu, I do have a coordinate system that's been set. And if I click on any one of these subbasins, the data shows not only the area, but it also shows the latitude and longitude, and it knows the outline of that subbasin, which is critical because it's using that for the centroid calculation. So we have latitude and longitude associated with each subbasin as well as with each gauge, which is right here. All right, so back to the meteorologic model. Here's 10-year. With interpolated precipitation selected, I'll click on that interpolated precipitation icon. And then down here in the components editor, what I'm selecting is the three 10-year gauges. I'm not selecting the 100-year gauge, but I do have all 6 gauges to select. Also, I'm going to leave the radius of influence empty so that all 3 gauges will influence the amount of rainfall that falls on all 3 subbasins. Up at the top here, I'm using the inverse distance squared for my interpolation method. So that's just a judgment call. You can use any one you want. After that, I created a simulation. So I went compute, simulation run manager. I have the 10-year, the 100-year, and then this test one I did that last. So with the 10-year, I can go ahead and select that, run the simulation, and then that's completed. All right, and then I can go ahead and look at my results. So if we want to pick on subbasin 1, for instance, we can go ahead and plot that data. The subbasin doesn't have any losses or infiltration or base flow, so what you're seeing here is purely all runoff. Up at the top is the hyetograph, and then here is the hydrograph. I did the same thing with the 100-year data, so if I go ahead and run the 100-year simulation, I'm going to go ahead and click on the results tab and compare the subbasin 1 runoff for 10-year and 100-year. So here's 10-year, here is subbasin 1, and then I'm going to expand the 100-year data and now expand subbasin 1. And now I'm going to hold down control and just click on outflow. This is for the 100-year, and then I'm going to hold down control and click on outflow. This is for the 10-year storm. Now if I click on the plot button here, I can bring this up to screen. The lower line right here that's currently highlighted, that's dashed. This is 10-year, and this is the solid line now here that's highlighted is the 100-year. All right, so that's pretty much what I expected to happen, and those are sort of the results I see here. Now, what I did in this last meteorologic model, right here, I called it test AB 10 year and C 100 year. So what that means is, just for fun, I created a storm event where I said that gauge A and B were going to be reading from the 10-year storm, but gauge C is going to be using the 100-year storm, which is about twice as much rainfall. So if I go back to the components tab and then I expand the meteorologic model, test AB 10 year and C 100 year, and then I click on Interpolated Precipitation, you can see what I did here. I said gauge A 10 year, gauge B 10 year, and then gauge C 100 year. So I just wanted to confirm that the results from this simulation would result in a hyetograph and also hydrograph that split the difference between 10 and 100 years. Now, if I'm going to continue looking at subbasin 1 here, the results are probably going to be closer to the 10-year data just because precipitation gauges A and even B are probably both closer to subbasin 1 than this precipitation gauge C way out here, which is the one I'm assigning to 100-year data. All right, so let's go ahead and run that test, and then boom. So let's go back to the results tab and do the same analysis we did before. Let's focus in here at subbasin 1 and then look at the results. So here's the results tab. Here's subbasin 1. I'm just going to expand all of these records first. Subbasin 1, okay, 10-year, subbasin 1. Okay, so here is the outflow for the 100-year. Here's the outflow for the 10-year. And then here's the outflow for the test. Okay, let me bring that to screen here. And then let me update the colors, plot properties. Okay, I've updated the colors. What you're seeing here in green is the 10-year runoff from subbasin 1. In blue is the 100-year runoff from subbasin 1. And then in red here, this is the test situation where I'm using 10-year data for precipitation gauges A and B and 100-year data for precipitation gauge C. And as expected, there is more runoff from subbasin 1. However, that runoff is much closer to the 10-year results than it is to the 100-year results, which is what I would expect if I'm using the inverse distance squared weighting method to determining the precipitation in that particular subbasin. All right, well, that was it for this support video. What we did was a lot of things. What we did was we created 3 hyetographs based on our assumed storm data, our precipitation depth, duration, frequency data. We imported that data into DSSVue using precipitation gauges that are time series data sets. Then we loaded that into HMS under the precipitation gauges here, linked that to our meteorologic model after we georeferenced our subbasins, and then ran the simulation and looked at the results.